Good morning. Today we are going to calculate the carrier concentration of electrons or density of holes in valence band. So previously we have studied about the calculation of density of electrons in conduction band. It is a continuation of that. So here we are going to calculate the hole concentration in valence band. So dP is equal to Z of E 1 minus F of E dE. So we know the value of carrier concentration of metals. We have derived this equation 4 pi by h cube 2m the whole power 3 by 2 e power half dE. So m is replaced by mh star and E is replaced by E minus E. EV is the topmost energy level of the valence band. So substitute it, you get the equation as 4 pi by h cube 2m h star the whole power 3 by 2 EV minus E the whole power half dE. Next, 1 minus f of E, Fermi distribution function formula, substitute it, solve it. We are getting the equation as e power E minus EF by kBT 1 plus e power E minus EF by kBT. Since kBT e power E minus EF by kBT is very small, we are considering the denominator is approximately equal to 1. So therefore 1 minus f of E is equal to e power E minus EF by kBT. So therefore P is equal to minus infinity, since the valence band extends from minus infinity to EV, the lower limit is minus infinity and the upper limit is EV. Substitute the value of Z of E and F of E. So taking out the constants, so we are getting the equation as 4 pi by h cube 2 mh star the whole power 3 by 2 e power minus EF by kBT between the limits minus infinity to EV minus E the whole power half e power E by kBT into dE. So directly we can't integrate this equation, so we are giving substitution EV minus E is equal to x. So where E is equal to minus x plus EV. So where dE is equal to minus dx. The limit, when limit E is equal to minus infinity, then the x is equal to plus infinity. Similarly, when E is equal to EV, then x is equal to 0. So apply this condition to the equation. You will get P is equal to 4 pi by h cube 2mh star the whole power 3 by 2 e power minus EF by kBT into EV by kBT. Between the limits 0 to infinity, x power half e power minus x by kBT into dx. So using gamma function, it is a standard integral value and the value of this integral is kBT the whole power 3 by 2 pi power half by 2. Substitute this and solving this equation, we are getting 2 into 2 pi mh star kBT by h square the whole power 3 by 2 e power EV minus EF by kBT. So we have to calculate the carrier concentration in intrinsic semiconductor. We know that in intrinsic semiconductor, the concentration of electrons and holes are equal. So Ni square is equal to N into P. Substitute the value of N and substitute the value of P and multiply this. And you will get Ni square is equal to 4 into 2 pi kBT by h square the whole power 3 me star mh star the whole power 3 by 2 e power EV minus EC by kBT. Since we want the value of Ni, we are taking square root on both sides. So the final equation becomes 2 into 2 pi kBT by h square the whole power 3 by 2 me star mh star the whole power 3 by 4 e power EV minus EC by 2 kBT. So here instead of EV minus EC, we are substituting the band gap energy. We know that band gap energy is equal to EC minus EV. So the final equation is Ni is equal to 2 into 2 pi kBT by h square the whole power 3 by 2 me star mh star the whole power 3 by 4 e power minus Eg by 2 kBT. Here it is EV minus EC, but actually Eg is equal to EC minus EV. So that's why we have applied a negative sign here. Thank you.